At the heart of SOLIDWORKS design is a 3D parametric solid model. It all begins with a 2D sketch, like a drawing on a piece of paper. I can use tools like lines, circles, and dimensions to begin the design. The dimensions are the magic of parametrics, like these offsets. No matter the size of the original circle, the concentric circle will always be a tenth of an inch away. Some parametric rules can be made on the fly. Here, one line will always be vertical because of how I drew it. I can add other rules later, like snapping the endpoints in place, or I can box select the line and the circle to make them tangent to each other, and finally snap the endpoints in place. SOLIDWORKS has a lot of time savers, like automatically putting in all the dimensions, or using the mirror tool to take advantage of symmetry. I'll fine-tune these dimensions, reattaching them how I want and resizing them. And now it's time to take this design into the third dimension. I'll create an extrude feature where I can bring any portion of my sketch into the z-axis. Notice I can use the on-screen ruler to quickly measure the exact distance that I want. I'm going to reuse the sketch again by picking it in the Feature Manager tree and extruding it again. This time I'll pick the upper regions of the sketch. Then one last extrusion to define the thickness of this webbing, and now I have a 3D volume that defines my component. If I give it a density, I'll know how much it weighs. Engineering is all about change, and making change to a parametric model is a snap. If I make a change to any dimension, the geometry instantly updates. I can quickly and easily edit sketch dimensions or extrusion depths right on screen. I'll save this part now and move to the next logical step, which is creating a detailed drawing. Once I've saved out the part file, I'll start a drawing. Picking an A-size piece of paper, I'll drag in the front view onto my sheet. Then I can project orthographic and isometric views of the model. Notice my design dimensions came over automatically. These are parametric also, so I just need to input a new number and all of the drawing views will update. More importantly, the associative part has updated too. This functionality is a two-way street. Changes made to either file will affect both. This is called associativity, and it's what makes parametric design the industry standard. Even with extensive changes to the model, my drawing views all update instantly. To get this drawing finished, I can use shading or change the scale on any view. I can also create section views. Note the automatic cross-hatching and dimensions. They came in messy, but SOLIDWORKS has tools to give nicely spaced dimensions. Now I'll delete the offset dimensions and replace them with outer diameters. We can see how SOLIDWORKS can quickly place and space reference dimensions as well. Once you've designed a few parts, you'll want to check for how they work together, so it's time to create an assembly. This is a model that's made up of separate parts. I'll search for a part number and then place it in my assembly. Let's grab that piston rod I just made and drop it into our assembly. Assembly mates allow me how to define how parts will fit together. SOLIDWORKS is always watching me, so when I select two pairs of parallel faces, it figures out that I want one part centered in another, so it moves like it should. Uh-oh, one part's inside the other. Interference detection can show me where part volumes overlap, or I can dynamically test for collision to see a true range of motion for this part. This assembly acts as a virtual prototype, allowing me to test for fit and function before I build. Now that I know the concept works, I'll continue building out this assembly by adding in this wrist pin. Again, I'll use mates to locate the part, even using references like the midplanes to center it. Okay, at this point I'm done with the assembly, and I'll save it out because I'm going to make a drawing of this as well. For an assembly drawing, I want to have a list of all the parts I need and to have each part on the list pointed out in the drawing. So again, I pick an A-size drawing and drop a view onto the sheet. The 3D assembly model is being referenced, so I can look at this from any angle. I'm going to right-click and choose to add a bill of materials at this point, which will be a schedule of all the parts that I need. And then I'm going to use the Auto Balloon tool, which will place pointers on all the visible components. These magnetic lines allow for neat, evenly spaced balloons. These balloons know what they're pointing at. See, when I move them to different parts, the number changes, so the balloons and bills will always be correct. Now, let's recap the true power of parametric associative design. No matter which file I edit, they're all going to rebuild. A change made anywhere is a change made everywhere, cutting down design time and reducing errors. Thanks for your time.